Hello everyone, welcome to your next section. Today we're going to teach you a little bit more about plotting and styling. So I'm going to go through more of that figure access and plot.subplot functionality we talked about before. We remember how we looked at the figure object, and that is a container to make your graphs, and then the access object from that is all the parameters we set in order to make your graph look the way you want it to. So we're going to spend a little bit more time learning about how to style our graphs. We're going to deal with a couple of features around that. So specifically what we're going to look at is we're going to have more practice with plotting. We're going to do some plot styling. So we're going to play with our access parameter and mess around with that, see what kind of things we can get it to do. Play with our our axes and limits and all that kind of stuff. We're going to deal with a little bit of subplotting as well. So I'm going to show you how to plot two subplots in a graph in one figure, basically, how you do that for rows or columns. And then I'm going to show you just a couple of other features that make Matplotlib very useful and usable to use, or usable for like graphing anything you want in Python. So with our syntax here, or our definitions rather, remember an axis is either the horizontal or vertical line that is representing values that we then place onto a graph. In a scatter plot, the y and x axis are determining our Cartesian coordinates, but in other graphs they mean different things. A legend box is if we have different symbols or some sort of visualization that we want to represent that isn't that needs to be kind of defined within the graph. Let's say we had a scatter plot and we had dots and crosses. You'd use the legend to delineate what a dot is and what a cross is. We're going to play with ticks a little bit today, guys. So we're going to manipulate how many ticks are showing up in our graph and what limits our ticks are being represented by. And so how about we just jump into it? There are going to be two syntax sections here. First, playing with how axes work, and then playing with how subplotting works. If we have enough time at the end, I'll show you how to plot something with a pandas data frame. But if we don't, we can end up doing that next time in our next class, where we work at scatter plots specifically and how we can style and manipulate features for scatter plots, just for that one plot type. So without further ado, let's just jump into our syntax and see what we got with plotting, styling, and manipulating axis parameters. So this is our first set of code that we're going to look at today. The first set, or the first couple of lines, are initializing our packages. So we're using NumPy because we're going to use this other random function that I'll tell you about. And then we imported Matplotlib for our plotting. So I created x and y values using a slightly different random feature as opposed to the random.randint. I've asked it for uniform numbers, like uniform distribution of numbers. I'm passing it a low value of 0 and a high value of 10, meaning I want numbers between 0 and 10 and 50 numbers. The difference between uniform and random int is that this is going to give me floating point numbers as opposed to just integers. I wanted to show you a uniform distribution, so I wanted to show you kind of like a normal distribution of data using a different function here, and that was the point of it. Our y has a low of 7, a high of 10, but they both have the same amount of actual elements in this list. And that's really important when you're plotting. That you have an x and a y, they have to have the same amount of numbers. Otherwise, it's not going to know how to plot it. All right? So just like we did before when we were creating our plots, we use plot.subplots, which gives you a figure object and an access parameter object. We're going to play with our axis object to get our figures to show different things. Okay? So this figure is saying, it's open, it has a container, and it's actually ready to, receive information on what it needs to plot. Maybe I'm going to plot one here, another here, another here, another here, and each of these objects would be an axis, axis 1, axis 2, and so on, okay? But this whole container is the figure object. So with that, now that we understand what that is, we've created a blank figure and an access object that is waiting for information to be taken in. We're telling it we want to add some padding to our margins, meaning we wanted to, if we had a graph like this, and this is 0 to 10, and we had 5, and we wanted the distance between these numbers, I'll put like 3 here, we wanted the distance between all these numbers to be kind of farther apart. we would play with the padding. Okay, and that's just sitting here, and we'll noodle around with these numbers a little bit so you can see how the padding changes. The other thing we're looking at here is if we wanted to change the aspect ratio of our plot. Usually plots are rectangular like this, oops, like that, because you want to show some information going on like that, but sometimes we do want them to just be like a straight up square. So this is saying, hey axis, set our axis values to equal across the x and y, so they're not different. Okay. Limits are on an axis how far these numbers go. So the y-axis limit in this example is from 0 to 10, and let's say this is 20 here, and the x-axis limit is 0 to 20 in this case. Okay, so what we're saying here is that we wanted to adjust the limits for our graph and data. We're saying we want our x-axis to start at 5 and to end at 10, and our y-axis to basically stay the same but start at 0 and end at 10. And that's going to influence what points are going to be shown on the graph, because if you have points that are like, the x-axis at 12, 20, that point is not going to be shown in this graph anymore because it's well beyond the limits. Lastly, what I'm showing you here is how to not only set and adjust what the ticks are, but it's saying how many ticks we want and what do we want to name the actual labels for the ticks. So this can actually completely customize what each tick is. Even if it's 0 to 10, you can have it can be completely random and even include strings in there as well. Naturally, if you want to do this with the y-axis, it's y-axis instead. The last thing you see here is to add grid lines to your graph so it's easier to see, and you'll see what that looks like once we get into our Jupyter Notebook. The last two lines here are producing the plot. So we're now saying plot, we have all these different access parameters that we've adjusted, and now we're saying plot the scatter plot of this x and y and show what it looks like. Okay, and we'll see what that looks like in a second. Okay, everyone, this should be a little bit pretty familiar to you. The first thing we're going to see here is our initialization of packages, and we have our x and y like we did last time, where we're creating a uniform distribution of numbers, 50 of them between 0 and 10 and 7 and 10. And what we're doing here is very similar as well, but rather than leaving the parameters blank, what we're saying is we want two plots. We want to create a subplot that when it's default, this is just like 1, 1, meaning we want one plot in rows and one set of plot for rows and one set of plot for columns. This is saying we want to create one plot like that and one plot like that, meaning we want two horizontal plots, but really just one column of plots. Okay, so then the first thing we do to create our first plot is that we say, okay, we did say, okay, we want to use our 2 by 1, and we want to select the first plot right here, okay? And then we then do our basic plotting, guys. Really simple. So we plot x and y, and then this parameter here is telling us what we want the dots to look like, okay? And what we want the connections for the plot to look like. So we're saying we want kind of like big circles, as opposed to, in this case, maybe like little dots, okay? We're giving this a title, the whole plot a title, and we're labeling this as test 1 score. But we're not done yet, right? Because we want to build two plots. So now we say, okay, plot subplot, we're calling this 2, 1 again, but we're saying we want the second graph now, and we're going to plot y in first and x next. So these should look very different, and we have a different plotting scatter point type here. We then add some labels, x and y. That's how we build labels for Matplotlib. Plot.x label, plot.y label, and I think there's a labels function as well that will let you do like all of them at the same time. But we set those. We then say show the plot, which will display in our Jupyter Notebook. And then if we want to save that plot, we use the .save fig, and we have to give this extension for it to know what kind of figure it wants to produce. Okay guys, let's jump into Jupyter now and play with this a little bit and see what it looks like. So first things first, we're going to look at this code base here. I'm going to kind of just like show things one at a time, all right? So we have all of this. This should run and show a graph Here's that graph there. You'll notice that there's a grid line here. I'm going to remove that grid line now, so you can see that the grid line is gone. We're going to remove this ax.margins and see if anything changes. So yeah, there you go. We set the y-axis to like margins for padding to 0, but let's do like 1 and 1 and now see how this changes our margins here. The x-axis at the moment is 0 to 10 and our y-axis is 7.0 to 10.0. This clusters everything together a little bit more. It adds more padding, so it kind of like creates, first off, you'll notice that the limits are a lot larger, but it's also changing the margins of this by 1 basically. Let's remove that margins because it looked fine as it was, and set our axes to equal and put our grid lines back on there. Okay, so this is an equal set. You notice how it's slightly different in terms of the amount of in terms of the limits, but they do have the same amount of distance for each of them. Now let's see what happens when we change our x and y limits using this thing here. We would expect that this is going to now cut off some of that data because we're saying we only want like half of the information basically. Let's see what happens. There you go. So it kind of removes 5 to 10 here, or it sets the x limit to 5 to 10, and you only get 0 to 10 kind of clustered up here. So it's making things a lot harder to read, but that's, you know, good to know how to set y and x limit axes. This next one is not only going to set the ticks, the amount of ticks, but going to label the ticks as well. So you see here, even though we wanted 5, it says range, 1 to 5, so there should be 4 numbers at least, I guess. Let's see what happens if we put in 6 here. It's going to error out. Yeah, so we make as many ticks as we want. So we said in this case we wanted 5 ticks, and then we labeled each tick manually. I was even able to label foo, like give it not just a number but a string as well. So that's how you can also do this with y-axis obviously as well. So that's an example of how you can manipulate axes features in Python's Matplotlib scatterplot functionality. The next thing I'm going to show you is how to build those subplots. So remember, we have here, we're creating our subplots, figure and axis containers. We have our plot 1, plot 2, and they're all very standard. So I'm not going to like do these one line at a time. I'm just going to show you what this all kind of comes out as. You'll see here it's a little bit messy because it's not knowing what points it needs to go to every time, but you will notice that they each have lines. I'll remove the lines from this one, and you'll see that there are different dot types. Let's even do that with this one up here, and you'll see as well. So, okay, so we created we said we wanted subplots. We wanted 2 plots like kind of stacked on each other horizontally with 1 column, 2 rows, 1 column essentially. So we go subplot, 2 rows, 1 column. The first graph, the second graph, we plotted x and y and x for each different graph, and then labeled all this as shown here. Okay, so we plotted that, we've shown that. Last thing we want to do is show you how to save a figure. So how to save a figure, make sure that you give it the proper name. If you want it to go to a specific folder, like in our, right now we are set to our Udemy Python scripts folder. So I don't need to path anything, but if you want to change the path, you got to make sure you do that. And you also have to make sure you give it this extension, otherwise it's not going to know what kind of figure to save it as. Okay guys, with that, let's just do our recap. So I know I said that we would be doing a little bit of plotting with pandas. However, I kind of decided near the end of this that it's probably best just to introduce this to you in our next section. You did learn a ton. So we introduced styling to you, and I showed you how each of those styling features worked. How you can create grid lines and change axes and manipulate, all the different parameters and dimensions of your plot using the access parameter that kind of gets sent into your figure container. So next time we're going to learn how to plot with pandas. It's really easy. It's kind of like a one-liner. But any case, with that, guys, thank you very much for listening to this lecture, and I will catch you in the next one.